today's episode of Future Says, we have Jonathan Blutinger, one of the foremost food experts on 3D printed foods. Jonathan, welcome to the show.
Thanks for having me.
Tell us a bit more about yourself and the types of projects you've been up to recently.
Yeah, so my background's all mechanical engineering, product design. I spent a lot of time in academia, a little bit in industry, but most of my work is looking at how to make food in a more automated, robot-controlled way. A lot of my PhD work was around digital cooking, which involves 3D printing food, cooking with lasers, all this future sci-fi stuff. And then more recently, I've been working with Redefined Meat, which is a plant-based meat company based out of Israel. And they are replicating fully marbled steaks, but all 3D printed using plants.
Okay.
So yeah, happy to talk more about that, but that's kind of my background.
Wow. Why food?
Because everyone's emotional about food.
Yeah.
I think it's kind of a hot take, but I feel like people are more opinionated about food than politics or religion in a lot of ways.
Mm-hmm.
Whenever you go to a restaurant, everyone's got their own orders, very customized. I also just grew up in the Mediterranean household. My mom's Italian, so cooking is an important part of life. You know, food is food. Food is love.
Yeah.
So I think it's always been a part of me. So it's kind of a passion of mine. And then design manufacturing is kind of my skill set. So it was kind of the perfect combination.
What does your mother think of 3D printed foods?
I think she finally came around to it a little bit. But yeah, no, I think she sees the greater vision, and I talked to my parents or family about it. I think once I kind of explained the moonshot idea of, you know, a chef that can customize meals for you, they're nutritious, and it's like having a nutritionist and a personal chef, it all kind of fits together a little bit. Like, okay, I kind of see that. But I think the word printing isn't a very appetizing word, so perhaps that needs to be changed.
Will it be changed?
I think yes, probably.
Okay.
I think printing, it depends. It depends who you talk to.
3D optimized food?
3 digitally crafted foods, perhaps.
I like that.
Or something. I'm still working on that. So perhaps you have some ideas, but I think people think printing, they think of industrial processes like plastics and metals. But when I talk to younger generations, like young nephews or nieces, I mention this and they think, oh, that's super cool. Like they don't have any preconceived biases or anything like that. So yeah, it's an interesting one.
Just finished a PhD?
Finished it about 2 years ago.
Okay.
And I finished my postdoc about a year ago.
Okay.
And then Redefined Meat, the company I'm kind of finishing up a contract with now, they funded my postdoc. And with them, I was working on texture analysis research. Mm-hmm. So because they're trying to mimic, because they're in the alt meat space, so they're crafting these replicated marbled steaks. It's really important, obviously, that they taste and they feel like real meat. So what I worked on was developing a machine that can sample steak and push it in distinct spots and create a 3D texture map of real steak and compare it to their product so that they can then match it and mimic it and make it as close to the real thing as possible.
Okay. And do you eat non-3D printed meat?
No.
You don't eat non-3D, so you're not a good judge of how similar they are?
Well, that's what the machine's for.
That's what the machine's? Okay.
I follow the numbers. I'm a man of numbers, man of science. So.
And the machine says it's pretty similar?
The machine says it's pretty similar for 2 cuts of steak. Another cut of steak they did was a little tougher than the one they're trying to replicate, but again, this is part of the process, so kind of understanding the differences and how can you change the nuance to make it the same. But yeah, it's part of a larger study that I'm trying to finish writing right now, which will hopefully be published soon.
Okay. Why do we need 3D printed foods?
It's the age-old question, isn't it? 3D printed foods, I think it's less about 3D printing. I think of it more as software. Why do we want to combine software with food? Because when you can combine software with a different domain, it just totally allows you to do things you weren't able to do before. So if we think about telecommunication with phones, if we think about hailing a cab on the street, you know, we thought that was totally fine just waving our arm, but now Uber, we have customization. I think you have a lot of these. Software basically allows you to get uber customized with what you're doing. And how that applies to food is it allows you to be more controlled and deliberate about the food you're eating. So in terms of nutrition control, in terms of how you want to assemble the meals to give you more types of flavor expression, it just kind of opens the door to allow you to actually control what you're eating in a much more high-resolute way.
Sure. I'm sure there's a big environmental mission behind 3D printed foods as well, with food shortages.
Yeah, a little bit. I'd say it's less That's a harder sell because right now it is a little bit energy efficient. It's
Okay.
not. It's not. It's energy consuming. So it's less about. I'd say it's less about being. Right now, it's not very cost effective. It's less efficient. It doesn't compete in a lot of ways that normal cooking does, but it allows you to assemble foods and make new types of flavor kind of mixtures that you couldn't do before. So it's about a different way of thinking, which is why it's less of an incremental benefit, more of just a divergence to what we're used to using.
Okay.
Yeah.
So it's as much kind of trying to replace maybe some existing things, but actually trying to create a brand new line of food, right? That taste that I would not know at all.
Effectively, yeah. I think that's kind of where I see the moonshot idea going.
Amazing.
But what a kind of one application which I didn't foresee starting my PhD was the alternative meat space. So that's kind of one of the reasons why I got involved with redefined meat because if you think about trying to mimic alternative meats and like real animal meats, you have all these fiber lines, you have muscle, you have fat, striations. If you think about a cut of steak, so using 3D printing, we can replicate the fiber lines, the muscle, the fat, the cartilage in a very precise way. We can get different cuts of steak. Once we print it, we can cut it and actually, get the same marbled pattern that we get in a real animal product. So it's really good for replicating things in a high resolution. So in that way, it can be applied to replicating animal products too.
Are there, like you said, animal products? Are there some products that are easier and some products that are harder, some food products that are harder?
Yes, I'd say so. I think harder, if I think about which ones are harder to deposit. Right now, when we're looking at our printing technology, again, I was developing this more in the idea of it being a commercial appliance one day in your kitchen. So typically, the medium which the foods need to be in is either a paste, a powder, or a liquid. So pastes that are more difficult to print with, I found, are vegetable products. Funny enough, because they're very high water content. So when you turn them into a paste, you need to use some kind of a thickener or something else to make it hold its shape. But yeah, I think it kind of depends on how you kind of prepare the ingredients to get them into a printable form. But right now, many things you can think of can probably be replicated on a food printer.
Okay. You briefly mentioned some of the challenges around energy consumption. Can you go a bit deeper into some of those challenges and if you foresee those challenges being alleviated, or what do we need to put in place to alleviate some of those challenges?
Yeah, I think aside from the energy piece, I think some more upfront challenges I've dealt with on a personal basis with developing this technology in a lab setting is the hardware and software that needs to be developed to support it. Because right now, none of that really exists on the market. Thinking about this on a high level, when we want to print something, we first have to design it in software, similar to anything you'd want to build, like say a glass or something like that. It starts at a design, and then you have to turn it into some sort of file that can then be manufactured. So in the case of a food printer, we'll convert some designs. So let's say we design a slice of cheesecake or some other confectionery dessert. We can design every little component and then have it fed into some other piece of software that will then turn that into a recipe file that our printer can then look at, print it, and kind of make it for us. None of that software exists right now. The only piece of that software that exists is just the design software. The other piece, we're using existing open source software to kind of accommodate our needs for the printer. But really, it's like we're trying to kind of reinvent, or we're trying to basically retrofit what's currently out there for our machine purposes. So I think that's one big hurdle. The other hurdle is the fact that our machine right now and many of the machines out there are open loop, meaning there's no sensory feedback in the process. So the ones who are closing the loop are the users. So the engineers, me and the other team that were designing things or making things. So they're mostly technological things, which again can be overcome. It's just a matter of manpower and time to apply these sensors and update the machines and that sort of thing.
So these machines, they're specifically for food?
Correct. The ones I've been working on, the ones I've been developing, is I'm talking strictly about like a food printer that can also cook and that sort of thing.
Yeah. It can cook. Okay, so it's actually making the foods and cooking the foods?
That's the intent. It's like think of it like a one-stop shop, like a digital cooking platform where you have like 18 ingredients, all these little ink cartridges in the front of the machine, and then you have two lasers which are facing down. So you pick up an ingredient, you can print with it, drop it off, cook it at the same time, pick up another ingredient. So it's like you'd be cooking something in the kitchen, except there's no human doing it. It's just a robot.
It's amazing. And our chefs, our butchers, are people embracing this idea, or is there a lot of resistance to it?
I think when I explain to them that it's not going to take their job anytime soon, they're more okay with it.
Okay. But will it take their jobs eventually?
Hopefully not. No, no, I'm not going to say they will. I think I see this as like again like a way to. I'm not gonna replace the way our butchers do their job. Or I think if anything, it just allows us to kind of find new use cases for it. I don't know where the use case for this is going to be ultimately. I can postulate and pretend like, oh, this is going to be in our kitchens, but like I said, I didn't predict this being used to make alternative meats one day. Or so really, I think right now we're in still the developmental stage, and like we're pushing the R&D forward as much as we can to show people what's possible. And then really, you just have to put this in the hands of people in the space that might use it and see where the chips fall.
Okay. Is there a restaurant that is serving 3D meat?
Yeah, there is. There are restaurants. Well, there's two parts to that. So there's restaurants that are using 3D printers and more of the back of the house to create, accoutrement or small things on a plate. I see them more as like visual pops on the dish.
Okay.
I see that as a big use case, and I think probably there are a few using them mostly around Europe. Or they're using 3D printers for decorating cakes. I've seen this a number of places. Or 3D printing nice chocolate designs. Typically, you'll see this in sweet confectionery applications because I think people are more okay with things looking more perfect if it's made out of chocolate or sweets. But if I like 3D printed your face onto a piece of chicken, I don't know how much you'd think that's as appetizing as if it was made of chocolate.
I'm not sure who would think that was appetizing.
Exactly. So there's a big connotation with different things, right? With different foods. But the other part to that you mentioned, but Redefined Meat, their 3D printed steak product is available on the market, and that's being sold mostly around Europe. They have restaurants you can go and try their product, similar to Impossible or Beyond, which is more widespread mass adoption in like the US. So yeah, you can go to the website and actually see like, if I want to try their steak product, you can go on the website and see where they're serving it.
Okay. Would that be more expensive product because of the expense in making it, or is that a competitive in terms of price as well?
No, I think it's I've only had it once or twice when I was in Europe and Israel where they're based, so it's pretty competitive, the same price. Okay. I'd say it's not anything astronomically higher or lower. I think it's right around the same point.
Okay, interesting. Yeah. So technology challenges obviously. Mm-hmm. But there must be challenges around regulation, around consumer acceptance as well, is there?
Yeah, I can speak more to the consumer acceptance of it, like I kind of touched on earlier. It's harder for me to speak on the regulation portion because, again, I've mostly experimented with this in academia. So I don't want to pretend to know too much about what it's like to bring this to market.
Sure.
I think the connotation, like I said, you hear about printing and food, and it doesn't sound like the most appetizing thing ever. My research has gotten a decent amount of press over the years just in terms of publications, and if you read the comments and take them to heart, then you have to have thick skin, I'd say.
Okay.
So my point in saying all that is, if anything, that kind of drives me more, I think, because it reaffirms for me that this is a new technology and something that people haven't really heard about. So I like the fact that it's something new and different, and not trying to convince people, but at least trying to educate people on what it is and how it's not a really alarming and scary thing.
Yeah.
Printing is literally just depositing ingredients. So what I like to say is if you've ever had pasta, if you've ever had a burger, a hot dog, you've had printed food. Pasta, it's extruded out of, these dyes and it's cut. Granted, that's more like 1D printing. A burger, I'd consider also that 1D printing because you have to turn ground beef and you push it through the press. So that's like it's printing in a way. So just picture that, except a machine is moving around in 3D space as it's doing that.
Yeah.
So effectively, it's the similar technology. I think where it gets interesting is when you integrate software into it, like I touched on earlier. It's like it just allows you to turn it into a more customized appliance, and it allows you to bring it closer to the consumer, which is where I think you see a lot of cool benefits in the future.
Okay. Anytime I ask someone that talks to me about 3D printing, I always say, what's the coolest thing that you've seen or have heard as being 3D printed? And they almost all say food or some type of food. So I think the word is out. This is something that is happening on a widespread basis. It's not just redefined meat. It's not just a number of small companies. This is a really nascent, buzzing industry, is it?
That's good to hear. Yeah. It's 3D printing in general has been around since the 80s.
Yeah.
It's not a new thing, like I mentioned. 3D printing in general. I think food first started about 2007. My original professor at Columbia, Hod Lipson, he was the first person I think documented in a paper to actually print with food. So yeah, it's been around for maybe a decade and a half or so, almost two at this point. So yeah, I think it's again, it's interesting why would people seem so opinionated about, especially like 3D print plastic, and it's like, it's like, oh, it's cool, but kind of the off factor is like at this point it's like, oh, you're just 3D printing plastic. But as soon as food comes into play, I think people are just so passionate about it, which it evokes such an emotional response. I think because I don't know, food is our sustenance for life. It's like I treat it like a medicine. I think it should be treated like a medicine. So if anything, in a weird way, it's more printing with food. It allows more transparency in the process. Because if you think about going to a restaurant, you see what's on the menu, but do you actually know exactly what you're eating? Do you get to go back into the kitchen and watch them make the food for you? Not necessarily. So what if you could actually see that happening in front of you, similar to where if you were cooking at home? Except, it's much more controlled because this machine knows all the micro and macronutrients, knows exactly how much quantity it's giving you for each ingredient. So it's just bringing you a lot closer to the food. But people, I think, they see automation, they see robots touching the food, and they get scared.
Yeah.
So I think it's just an education thing.
Yeah. So in terms of your education, mechanical engineering degree, then you went and did a master's of some sort?
Yes, so my undergrad was mechanical, a master's in product design.
Okay.
And then I worked for a year in industry working on other robots, like robot gantries. And then I did my PhD at Columbia, postdoc, and then just finishing this contract with Redefined Meat.
Yeah.
And then, yeah.
In that postdoc then, talking about 3D printing, specifically of foods?
Postdoc was more towards the texture analysis research I touched on. But yeah, I was still working on the food printing as well with some other students.
Okay. So how many people are doing those things? How many counterparts did you have? Lecturers did you have?
Oh man, I'd say over the course of my let's call it 6-7 years at Columbia, I've had probably about 40 students.
Okay.
40 to 50 students over that period. Granted, every semester is maybe 3 to 4 students, somewhere in that ballpark. Have touched this project.
Okay.
And then before my time, we were also working on this, but I came into it mostly looking at lasers, characterizing lasers for cooking purposes. That was kind of the core of my PhD. And then I brought back in the food printing portion over the last couple of years to create this machine that can do both. So yeah, there's been a number of students who've touched this project, mechanical, computer science, electrical engineers, to kind of help it get to this point. So yeah, by no means is it just me, but it's a group effort.
What's the trickier part, the printing or the cooking?
They're difficult and they're difficult in different ways. It's kind of a cop-out answer, but I think the hardest part with printing is understanding, like getting the right formulation for the ingredients. What I mean by that is you might think usually the formulation we go for like a rheology for like the material properties, something close to like peanut butter. Peanut butter is like the ideal printable ingredient. So when you're printing meats, that works pretty well. You don't have to do anything to the consistency, but sometimes we have to add water or we have to add some sort of like other thickening agent, which we have to get at the grocery store to kind of get, so like you become a food formulator by proxy, like not on purpose. So that in itself is an entirely different PhD, but we had to kind of go qualitatively to figure that out. And the cooking part, I'd say the issue with cooking is probably, I I don't know, your intuition for cooking is mostly around ovens, stovetops, different types of cooking, but with lasers, the wavelength has a big factor on it, the power, the speed at which you scan the food. There are so many variables you can control that sometimes we just have to keep a couple of them constant and just tweak one of them. So it's a good problem to have, but it also makes it difficult because you're constantly juggling all these variables and you want to keep as many of them constant and just fool around with one or two.
I have to ask then, AI, can that help?
Big buzzword right now, AI. AI can definitely help. And we did apply this. I'd say we applied machine learning, which is a form of AI, in one of our studies. What we did is we looked at, like I mentioned, all these variables. It's definitely a great application for machine learning because what we did is we took a piece of dough and we hit it with the same laser. Just we changed the power, the speed, and one other variable, the scan pattern, which gives you implications on how much power is actually being received by the dough over what period of time. And we did this for a bunch of different tests, and then from that we took images of it, and then we extrapolated. Okay, if you want this level of brownness, what do your laser parameters have to be? If you want this level, what are they going to be? So we did apply it in that way, and I think you can apply that to a lot of different foods, and you could start to get smarter about it. And so yeah, I think in short, you could definitely apply machine learning to this process to optimize the cooking parameters, but you also need some sort of vision system in, I think, whatever kitchen appliance is going to be using either food printing or laser cooking, because at the end of the day, as chefs, we cook with our eyes open. We don't cook with our eyes shut, but right now our machines are doing that. So you need to have some sort of feedback loop where you can actually see what's happening at the same time, and then it can make adjustments on the fly.
Is that the next steps from a tech perspective then?
I think it definitely is. I think for this to be a commercial appliance, it needs to get to that point. That's something I've kind of been pushing the students that I've been working with over the years to kind of look towards. Like, let's think about maybe making this smarter. Let's integrate some sensors. But there's always so many things that can be tweaked. So it's like a matter of our priority list. So I think that's definitely something that I'm really excited to see. How can we make this less manually intensive from the user perspective? So that's one of the things I'm looking at.
Okay. Is your goal, I mean, obviously, being based in London, you have Pret in London, and they're cafe using these huge coffee machines that you would never have at home. You generally have a much smaller coffee machine at home. So do you think that's where we're going, that we'd have in, I don't know, the big restaurants or the big distribution chains, they'd have a big printer, and then maybe at home in the future you could have something yourself? Do you start with the bigger volume?
Yeah, I think right now the issue is the price point, and just the fact that you need to be an engineer to learn how to work the machine. So as it gets smarter, as you build in these sensors and the UI UX, it'll move from like the manufacturing stage to closer to the consumer. I think that in between stage is, like I mentioned, like restaurants starting to apply it. Maybe I think ghost kitchens is a really interesting application because the users don't get to see it, but it saves the companies on their bottom dollar, I think, once you figure out the right use application for the actual piece. So I think those are interesting applications that will start to happen. And then eventually, when the technology gets compact enough, user-friendly enough, and people are familiar with it enough, it will start to pervade our homes in a big way.
Okay, so the UI UX is a really important point. At the moment, that's not... I wouldn't be able to control that machine at all.
You'd be frustrated.
Okay.
I'm frustrated with it. It's been my baby for the last 6 years. Sometimes I think it has a mind of its own, so maybe the AI is taking over. But no, I think aside from just the UI UX, it's also just availability of these. I'll say it's the complementary markets that need to help sustain it. So what I mean by that is, the analogy I like to use is like we've built this amazing iPod, but there's no iTunes store. There's no way for you to buy music, to even make music. So unless you're an engineer or the person actually designing these meals, there needs to be a community and a kind of a place for you to buy recipes, the ingredient cartridges, things like that, which doesn't currently exist. And that's what another big headache is when we're trying to print these meals. is the loading ingredients, getting them ready. So the preparation time is like 90% of it. The printing time is only like 10%. It just takes so much time to prepare the foods before we actually print them.
How much time?
Man. Okay, I'll try to give you a realistic example. So we printed this like 7 ingredient cheesecake, which we got published recently. It took us 7 design iterations to actually get a successful print, and so every print took about 30 minutes, 40 minutes so that many failures and then one successful one at the end. But preparation time for every print probably on the order of like 3-4 hours.
Okay, 3-4 hours.
5-6, yeah.
But 40 minutes.
A full day
cooking.
Yeah.
Yeah.
Of prep.
For baking though, that's not bad.
Correct.
Yeah.
Probably not. But for baking,
Right
you're also
application.
following instructions. And you know exactly it's going to work. And this, we don't even know if it's going to work. That's
black box. You don't know what's happening underneath.
Effectively, it's like we're still building our intuition. Yeah. That's how new it is. So it's like at this point, I think I've gotten really good at knowing if a design's going to fail or not. Because again, it's a function of the rheology of the ingredients you're using. Because some of them are structural, some aren't. So we've learned this through this process, which is good because you have to learn it in order to. You need to go through all the bad stuff to get to the good. Yeah. So we've learned it, but I think for most people, if I were to give you a bunch of ingredients and say, okay, here are 5 ingredients, make me a pyramid structure or some kind of more complex structure. I think I could almost guarantee your first 3 designs are going to fail.
Okay,
but you should take on the challenge, maybe.
I would love to. How do you do that test then? Was it 7 times you did the cheesecake?
Yeah, 7 design iterations.
So how did you decide that the first 6 were not good? Was it a taste test or
mostly visual?
Okay,
visual. They crumbled.
So they just look bad. Okay.
They look bad. They crumbled. Yeah, there's. I'm sure if I showed you video footage of it, you'd be like, okay, yeah, this is a clear failure.
Okay.
But the good thing is, it's still food, so it's still gonna taste pretty decent. But it might not look like the most appetizing thing.
So the 7th one looked good. Did it taste good?
I thought it tasted pretty good. It was like 70% graham cracker, which in retrospect is probably a little too much for my liking. It was a little too heavy on that, so I probably would have added another ingredient in there or like some kind of cream cheese on top. There's always more that can be changed. Even as the designer, and I say it's a success. I mean success structurally, but then there's like the taste factor. There's the flavor. There's so many things. So. Another reason why I think if you had a large AI network where you factored in all your 5 senses, it'd be a lot easier.
Very interesting. So my brother lives in Copenhagen, and he is a baker in a bakery called Lila. And he loves technology too. So I think this will be really interesting to put this past him and see what he thinks.
Yeah, it'd be interesting. There's a random aside since you mentioned your brother in Copenhagen. There was another chef recently who got in contact with us. Sometimes we'll have random chefs who want to use this technology, and I have to kind of put it into perspective and say, okay, this might take a while. It's not we don't make it as glamorous. It's not as glamorous as it looks, but he's trying to mimic filigree, which is like an Albanian, this almost looks like a jewel on top, and it's like really fine design. And he saw our technology. He's like, "This could it do this?" So we're messing around with it right now. But I think for high, chefs who are doing pastry chefs or fine dining chefs who want this finesse in that they can't control with their hand, but they want to have nice, clever designs on top of their foods. It has an interesting application towards that too.
So this machine, who owns this machine? This is a machine that you've built alongside colleagues.
The machine that I'm referring to is still the one that's at Columbia.
It's a Columbia's machine
I've been developing as part of my PhD.
Okay.
Part of the lab, basically.
Okay.
Yeah.
Would you love to spin that out at some point and have that at you full time?
I would. I definitely would. I think I see this as an inevitability. It's just understanding the right key players to go after, understanding the business model a little bit more, and another kind of strategic partner who could figure out the right market for it. Because I think there are a lot of interesting markets for it. But I think I want to develop it a little bit further, understand a little bit more of the space, and then once I feel pretty confident about it, I think it might be good to do.
Okay. But the immediate next steps, you're finishing up at Redefined Meat. What comes next?
Yes, finishing at Redefined Meat, and in a couple of weeks, I'll actually be joining the Army. Not enlisting, but I realize I should have said that differently. I'll be working with the U.S. Army on their combat feeding division. So they have a division that's devoted towards developing new tech for soldiers in the field to make it more efficient in making food for them. So they're looking at food printing, especially for customized meals for soldiers. And yeah, I had a brief view at their lab 2 days ago, actually, when I was in Boston, and
Wow.
they have a lot of really fun gadgets to play with, to put it lightly. So I think it'll be a really interesting work, and we'll see where it goes.
My gosh. And so you'll be the only person doing this in the army then, or is there a team already?
There's a team there, a small team that's working on this specifically, but there's a lot of people working on food innovation related things at the Army. But a small subset are just doing food printing. So
It's amazing.
we'll see what happens.
Did they do? I mean, you haven't even started yet, but
Yeah.
do you know? Do they have kind of an objective? Is there a defining thing by the end of 2025 or something like that that they're seeking to achieve?
I don't know their clear objectives. This is something I'm really curious to know too. But I know they want to work towards a machine that can be versatile and that can be robust in austere environments. Because you picture soldiers in the field, a situation where you need a chef on the go sort of thing, something that can be broken down, reassembled, that can make food for you. Then you're on your next mission or your next, whatever. Or maybe something that's more in a barracks or more, a troop support station or something like that. So there's many different applications I could foresee this being used by them, but those are just a few that I've heard of.
Amazing. Last question. All of that, what's the one thing that excites you the most about 3D printed foods?
I think it'll be really interesting to see once we have a machine that is closed loop, it can follow your eating habits, when it can actually start to predict what you're going to eat before you want to eat it and actually make that for you. So again, I think about this like a nutritionist and a personal chef. So if it gets to the point where it knows your eating habits, your biometrics, it can predict what you like and just make it for you on the fly. That's when I know it's gone to a point that I didn't believe was possible.
It's amazing. I mean, on this podcast over the last few weeks, we spoke to so many different people in so many different industries, and a lot of roads all lead to personalization. Personalization of food, personalization of cars, personalization of medicines. It's a good time to be a consumer.
I'd say so. I think it's just, again, it's all software-enabled technologies. It's like, yeah, everyone wants things personalized. They want it their way. And it's inevitable. So I guess you just got to get on the train.
Amazing. Exciting. Jonathan, thanks so much for joining.
Thanks so much.